Hey, so we're going to look very, very briefly at section 3.9 on differentials. There's a whole lot in this section, but we only want a little bit of it, and it's going to be something that we'll use a little bit later when we learn how to do integration by substitution. So pay attention in the homework to the problems that I've assigned, because most of the stuff in the chapter we don't need. So first of all, let me just give you a definition. If y is equal to f of x, we define the differential of y to be this. The notation we use is dy, and it's defined to equal the derivative of f multiplied by dx. So you can think of that dx as something formal now, but you can think about it as representing a small change in x. So for example, if y is equal to x to the fifth, then dy is found by taking the derivative of the function, so 5x to the fourth, and writing dx after it. Easy as that. Of course, on the test, you'll probably see problems that involve the quotient rule or the product rule or maybe chain rule. So for some examples that look like that, let's say that y is equal to x times sine of x. In that case, we first of all have to take the derivative of x sine x using the product rule. So thinking of this as u and this as v, it'll be u prime v, so 1 times cosine x, plus u v prime, which is x times cosine x. That's the derivative, and then to make it the differential, we write dx afterward. Of course, you do need to remember how to take derivatives of your trig functions. So for example, if y is equal to tangent of x, then dy is the derivative of tangent x, which is secant squared x times dx. And finally, if we use different variables, then we have to adapt accordingly. So for example, s is equal to t over t plus 1, then we'll write ds for the differential. And here we're going to need to use the quotient rule to differentiate. So it'll be the bottom times the derivative of the top minus the top times the derivative of the bottom over bottom squared times dt, since our independent variable is t. Simplifying just a little bit, that's t plus 1 minus t over t plus 1 squared. The numerator simplifies to 1 over t plus 1 squared. This is a fine way to write the answer. Sometimes you'll also see it written with the dt in the numerator. Now, if you want to read more about what differentials are used for in physics and other places, you can check out section 3.9. This is all you're going to be responsible for in this class.